So in this video I'm going to go through a series of probability calculations, and it's going to be based on a contingency table that was generated in the previous video. So please go back and review that one if you're interested in how to generate the table. So the table summarizes the smoking status and indigenous status for 1,000 individuals, and using this table we're asked a series of questions. So the first one is, what is the probability that a randomly selected individual is indigenous? So to write this out, we say P for the probability of our event, and that's that we have an indigenous person that we randomly select. Now you can see I've got some little abbreviations here to try and make it quicker to write these out. So indigenous, I'm just going to use IND. And we should be able to take this from the margin of our of our contingency table. And the margins are just basically where we have these totals. So indigenous, we've got a total of 50 people that identify as indigenous out of the overall total, which is 1,000. So that includes the people who are not indigenous. So if we type this into a calculator, we end up with the answer of 0.05. So that's the answer to part A. So part B is, what is the probability that a randomly selected individual is non-indigenous or smokes? So this one is a union question. So we can write this as P for the probability. So non-indigenous, I'm using this as my abbreviation, so NIND, or smokes. So U for union, that's the symbol, and then smokes, it's SM. Let me just jot that in. So remember, the union is we're looking at the chance of someone being non-indigenous, or someone being a smoker, or someone being both at the same time. So we can write the equation for that. So it's the probability that the first event happens plus the probability that the second event happens minus the probability that both happen at the same time. Otherwise we're double counting them. So not indigenous and a smoker at the same time. Remember, this one here is the one for intersection. So that's the AND. Alright, so going through and filling this out, this has just become a marginal probability now. So probability that you're non-indigenous, coming from the margin here, so 950 out of the 1,000 people, plus the probability that you are a smoker. So smoker, the total here is 390, again out of the total people, which is 1,000. Minus, we need the probability that you're not indigenous and a smoker at the same time. So smoker, not indigenous, so it's the intersection of these two row and column. That's 363 out of 1,000. So if we go and type that into a calculator, we should get our answer out, and I got about 0.977 as the probability there. Alright, so the next one is part C. So what is the probability that a randomly selected individual is non-indigenous and does not smoke? So this one is an AND, which is like an intersection question. Okay, so non-indigenous and not smoking. Sorry, probability not indigenous, so and sorry, does not smoke, so NSM. Cool, so this is the same symbol as this one over here. It means they're intersecting the row and the column. So we're looking for not indigenous, which is this column, and not smoking, which is this row. So the intersection there is 587 divided by the total number of people, which is 1,000, and that comes out to 0.587 as the answer. Alright, part D. What is the probability that a randomly selected indigenous person would not smoke? So this one is becoming a conditional probability. So remember that conditional probability, we write it out like this. So it's the probability of event A conditional on event B. So in our case, we're looking for a randomly selected indigenous person would not smoke. So the condition is that we need to pick an indigenous person. That's fixed, okay? It's the smoking status which may change. So indigenous is the condition, not smoke is the event. So that's how we write it. Remember the second one, okay, is the condition. So the equation that we can write out is the probability that we have the intersection between these two events divided by the probability of the condition, so Indigenous on its own. So this is just again looking for the intersection of those 2 points, so not smoker and Indigenous. So not smoker and Indigenous, that's going to be the 23 there, and it's out of the total number of people, which is 1,000, divided by the number of, the probability of just being Indigenous. So looking at this one, the marginal probability is 50 out of 1,000. And what we find is that the 1,000s cancel with each other, so we're left with 23 out of 50. And if you type that in a calculator, it comes to 0.46 for your answer. Alright, so E. This one we want the probability that a randomly selected smoker would not be Indigenous. So this time the condition is smoker, so we know we're definitely going to have a smoker, that's not negotiable. What changes is their Indigenous status. So smoker is the condition. So when we write it out, smoking needs to be the condition, so the second one. The first one was non-Indigenous. So again, we can write it in this form. So that means that we're looking for the probability of the intersection of the two events divided by the probability of what we've got as our condition. So we need the intersection of non-Indigenous and smoker. So non-Indigenous and smoker, the intersection is 363, and that's out of our total number of people of 1,000. And then the probability of being a smoker, take that from our margin, so that's going to be the 390 out of 1,000. So again, these 1,000s are going to cancel with each other, and we're left with 363 over 390, and as a decimal that's about 0.931. Alright, so I think we just have one left, which is part F. So part F is asking us, do Indigenous status and smoking status appear dependent or independent, and why? Alright, so I'm just going to copy our table down. Here we go. So we're looking for the independence of smoking and Indigenous status. So for this, the probability of an event in its unconditional form has to be equal to the probability in the conditional form for it to be independent. If this is not true, then we've got a dependent case. So let's pick one of our variables to have a look at. I might pick one of our categories, I should say. I might pick Indigenous. Oh, just writing this as IND. So the probability that someone is Indigenous, we did that one before, it's going to be 50 out of 1,000, so about 0.05. So now if we look at the conditional form, so the condition that we can put on that is you might be Indigenous and you might also be a non-smoker. So okay, so what we're looking for here is if you're Indigenous, if you're a non-smoker, what is the chance that you're Indigenous? Other way around. So again, this is where we can write it out with our other form of the equation, where we look for the intersection of Indigenous and non-smoker. Write this as NSM, sorry, and divide by just the probability of being a non-smoker. So the probability of intersecting these two events, so it's going to be this column and this row, it's 23 out of the total of 1,000 people. And the probability of being a non-smoker is 610 out of 1,000. So again, these cancel and you get 23 out of 610, and this is about 0.038. So straight away what we can see is that this is not equal to this, so we haven't really got an independent case going on. Let me just do one more to illustrate that further. So we can look for the probability of someone being Indigenous, conditional on them rather than being non-smoker. Let's look at it conditional on them being a smoker. So again, we can write this out nicer and calculate the probability. So we need the intersection of these two events, so this row and column, so it's going to be 27. And the probability of someone being a smoker is going to be the 390 out of 1000. Again, these cancel, so we're left with 27 divided by 390, and this works out to 0.059. Okay, again, it's a different number to what we had up here for the unconditional case. These two are the conditional ones. So what we can say here is that Indigenous status and smoking status are really dependent on each other. Okay, you can say that there is a higher chance of being an Indigenous smoker, which is this one here, than being an Indigenous non-smoker. Okay, so my conclusion here would be that smoking status and Indigenous status are dependent. Okay. And that's because the probability of being Indigenous did not equal the probability being Indigenous conditional on being a non-smoker or being a smoker. Okay, these were all linked together. So that's all I've got for that video, and I'll see you in another one.